Hello students, today we will solve another problem. This problem is basically from work energy and power. This problem is from class 10 as CSC board, Selina book exercise problem. So we will solve this problem. The problem is like this: a body when acted upon by a force of 10 kgf gets displaced by 0.5 meter. Calculate the work done by the force when the displacement is in the direction of force, and second, at an angle of 60 degree with the force, and third, normal to the force. You have to take the value of acceleration due to gravity equal to 10 Newton per kg. So before proceeding for the solution of problem, we will see expression for work in detail. So there are some circumstances in which a force displaces the body, but there are there are also some other circumstances in which a force is displacing the body, but the displacement of body is not in the direction of force. Suppose you have this case like this. Here a body is, you have any body, and this is the direction of force, okay, and the displacement of body is in this direction, okay. So here the displacement of body is not in the direction of force. So we will see in detail how to find the expression for work in this case. The first way is to find the expression of work by finding the component of displacement of the body in the direction of force. And second case is by finding the component of force in the direction of displacement of the body. There are two cases. First, by finding the component of the displacement of the body in the direction of force. And the second case is by finding the component of force in the direction of displacement of the body. So we will see these two cases in detail. First, we will see first case. Now we have, suppose that this is a any body and we are applying a force on the body, and the direction of force is along the AB, and the direction of displacement of the body is along the AC. So direction of displacement of the body is not in the direction of force. So in this case, we will take the component of displacement in the direction of force. Now there is one other thing. The direction of displacement and force, they both are making an angle theta. So here this is an angle theta. Okay. So for taking the component of displacement, we will draw a perpendicular from C to B. So it is a we will draw a perpendicular from C to B. So CB is a perpendicular, and this AB is the direction of force. So in triangle ABC, we will use cosine of angle. Cos of theta is equal to base upon hypotenuse. So here base is AB and hypotenuse is AC, and AC is S. So if we have applied force here on the body, and the body starts moving and it reaches to point C, okay, and this whole length AC is displacement. I am naming it as small s. Okay, so here AC is S. So now we will find the value of AB from here. Okay, AB is equal to S cos theta. So we have got the component of displacement in the direction of force. So here expression of work will become F into F is force into component of displacement, that is S cos theta. So this is the expression of our force by taking the component of displacement in the direction of force. Now we will see second case. Second case. By finding the component of force along the displacement. So we will see this also. Now here see, uh, this is your any body, okay, and here vector PA represents the magnitude and direction of force, okay. So in this case we will derive expression for force by taking the component of force in the direction of displacement. Here AC is the direction of displacement and PA is the magnitude and direction of force. Then the component of force in the direction of displacement is NA in this case, okay. So here we will apply basic mathematics to derive the expression for work. So here work done will become W is equal to NA, that is component of force is NA into AC displacement. So here W will become, that is our work. So NA we will calculate NA for this. So what we will do here for calculating NA, CB is perpendicular, okay. So calculate NA. What is the magnitude of NA? Okay. So here, as we all know, cos theta is based upon hypotenuse. So here base is NA in triangle PNA. Base is NA and hypotenuse is PA, which implies NA is equal to PA cos theta. And PA is magnitude of F, so NA will become F cos theta. Okay, so our work will become Fs F into S cos theta. So we have got the same expression for work in both the cases, that is W is equal to F into S cos theta. Now we will solve our today's problem. So students, we will solve our problem. So our problem is a body when acted by a force of 10 kgf. So here 10 kgf means mass is 10 kg and g is 10 Newton per kg. Okay. Gets displaced by 0.5 meter. Displacement is 0.5. Calculate the work done by the force when the displacement is in the direction of force, and second at an angle of 60 degree with the force, and third normal to the force. So first we will calculate first part of the problem. So here the expression for work is W is equal to F into S cos theta In the first part, you have calculated the work done by the force when the displacement is in the direction of force. So here, if you will, if force and displacement they both are in same direction, okay, when the displacement is in the direction of force, then in this case the angle 0 degree and it is equal to 1. So here your expression for work will become W is equal to F into S. So W force is 10, mass is 10 because, and your acceleration due to gravity is also 10, and kg Newton per kg into displacement, that is 0.5 meter. And if you will simplify this, 10 into 10 100, 0 into 0.5, you can write 0.5 as 5 upon 10 in fraction form into Newton meter. So your work will become 10 10 100, 10 into 5 50 Newton meter, which will become 50 joule. So this is the solution of first part of the problem. Now we will see second part. So second part, at an angle of 60 degree with the force. This time the displacement is at an angle of 60 degree with the force. So now see. So here, if you have, sorry, let me make the straight line got dejotted. Consider this is a straight line, and this here, this is any body, and this is the direction of force, that is along AC, and AB is the direction of displacement. Now this time displacement is making an angle of theta, that is equal to 60 degree, you have given in the problem. So here your work will become, expression for work is W is equal to F into S cos theta. So here you have angle given, magnitude of force is 10 kg, acceleration due to gravity 10 Newton per kg into S, that is displacement 0.5 meter, and angle theta cos of 60 degree, the value of cos of 60 degree is half. So here, if you will simplify this, 10 into 10 100 by 250 into 0.5 Newton meter, and W is equal to 50 into 5 by 10, 10 5 ja equal to 25 Newton meter, which will become 25 joule. And the last part of the problem is when the displacement is normal to the direction of force. In this case, theta will become 90 degree because normal is perpendicular. Okay, so you know the expression of work, Fs cos theta, and if you will take 90 degree, the value of cos 90 degree is, it is 0. So your work will become 0. So in this way We have solved all the three parts, and if you will see first part, the magnitude of work is greater because displacement is in the direction of force, and in the second part, the magnitude of work decreases because in second part we have taken the component of displacement in the direction of force, and in third part your total work is zero because displacement is normal to the direction of force. So we have, please like, share and subscribe my YouTube channel. That's all. Thank you.